The title of the presentation is Detecting Forest Health Using Remote Sensing Techniques, a case study of Calabar Reserve, Forest Reserve in Cross River State, Nigeria. The core question here is, how can we manage forest ecosystem sustainably? And one of the key issues in forest ecosystem management is forest health. How do we detect or monitor forest health? And classically, this has been done using in situ methods as field survey method. But with the advent of remote sensing, it could be it gives us a better option to detect and manage forest health. In this study, we used Moody's products, Moody's NDVI products, EVI products, ETS, and rainfall data to actually detect forests in the study area. That's exactly what we did in that case. Now, actually, what it means is that for this, there are a lot of factors that affect health. You have abiotic factors. You have also biotic factors. You have issue of soil nutrient. You have also issue of precipitation. For this study, we concentrated on greeniness. How green a vegetation is will determine how healthy it is. So we used vegetation indicators, which I had mentioned, which we can obtain from Moody's products. That's exactly what we did in this study. Then if you turn to the data and methodology, you find out that we tried to look at variation, the spatial variation and temporal variation of vegetation health over a year, that over 2018, from across the seasonal, that is the rainy season as well as the dry season. That's what we called autumn, and autumn, spring, and also winter. That's exactly what we did. So if you watch out in our methodology, you have actually the procedure through which we use to extract NDVI, EVDI, and also ET. That is ETA. That is ET, which is evapotranspiration. That's exactly what we did in that case. If you move again, by the time we extracted these things, we had to produce. If you turn to your table, as it results and presentation, you see you have about 8 forest reserves in Calabar. You also have a temporal variation, which is through winter, spring, summer, and autumn. In our own case, the winter and autumn is the dry season, and the spring and summer is the rainy season. You can see that you have the indicators there. You have NDVI, and what NDVI does is that it gives you an indication of how healthy vegetation is. You also have the EVI. What EVI is enhanced vegetation index, and the other one is normalized difference vegetation index. You can observe through that table. You find out that for winter, you have rainfall data, which was constant, which is about 5.37 millimeter rainfall all through the forest. And you also observe that there is a variation in the value of those NDVIs you have for all the forest. That's exactly what happened in that case. So with this, you can have an indication of how the health of these forests is changing over time, as well as you move from one forest to the other. That's exactly what we did in this study. To conclude, what it means is that the greeniness of a forest reserve, as shown in positive trend in NDVI, indicates a net increase in biomass production during the year 2018. The 8 forest reserves are moderately healthy, but wet autumn is healthier than other, judging from the yearly mean value of 10. We now recommend the need for further multi-temporal evaluation of forest reserve to actually detect the rate at which they are deteriorating or improving in health. I think I'm okay. Thanks.